Hi friends, today I will solve another CSIR Net 2023 problem. The problem is like this: a system of two identical masses connected by identical springs, as shown in the figure, oscillates along the vertical direction, and you have to calculate the ratio of frequencies of the normal modes. So it's a little bit lengthy problem, but we will proceed for the solution. The system is like this. We have two identical springs of same spring constant K, and two masses are connected through these two springs, and masses are also same. Let the displacement of spring 1 and spring 2 be x1 and x2. The kinetic energy of the system is T is equal to half m x1 dot square plus x2 dot square. We have generalized coordinates x1 and x2. The potential energy of the system is V is equal to half K. For x1 we have only one and, so it will be half K x1 square, and if we will stretch this x1, then there will be compression in x2, so your potential energy is half K x1 minus x2 whole square. We will rearrange potential energy term, then it will be half K 2x1 square plus x2 square minus x1 x2 minus x2 x1. Uh, we will create a matrix of kinetic and potential energies, and the matrix will be of 2 cross 2 because we have generalized coordinates of up to x2. So the kinetic energy matrix term is given by Tij equal to del 2 T upon del eta I dot into del eta j dot. So our T11 is given by del 2 T upon del x1 dot into del x1 dot. So our T11 is m. If we will go for T12, then T12 is del 2 T upon del x1 dot into del x2 dot. Our T12 will be 0. Similarly, if you will calculate T21, then it will be 0, and if you will calculate T22, then it will be m. So our kinetic energy matrix will become m 0 0 m. Our potential energy is V is equal to half K into 2x1 square plus x2 square minus x1 x2 minus x2 x1. If you will go for Vij, that is potential energy matrix term, then it will be del 2 V upon del eta I and del eta j, which implies our V11 is given by del 2 V upon del x1 into del x1. Then our V11 is 2k, because if you will differentiate del 2v upon del x1 and del x1, then it will be become 4x1, then x1, then it will be divided by 2, and then it will become 2k. If you will go for v12, then our del 2v upon del x1 into del x2, then our v12 is minus k. Similarly, if you will go for v21, then you will also get minus k, and if you will go for v22, then you will get k. You can calculate. Then our potential energy matrix is our v11 is 2k, v12 minus k, v21 minus k, and v22 k. For calculating normal modes of frequency, we have to use secular equation, and secular equation is v minus omega square t. Determinant of v minus omega square t is equal to 0. And here omega is a normal mode of frequency. It will satisfy this equation. So we will proceed for the next step. Mod of v 2k minus k minus k minus omega square m 0 0 m is equal to 0. Then we will get 2k minus omega square m minus k and k minus omega square m is equal to 0. We will get 2k minus omega square m into k minus omega square m minus k square is equal to 0. 2k square minus 2k omega square m minus omega square mk plus omega to the power 4 m square minus k square is equal to 0. If in the next step we will rearrange our equation, omega 4 m square minus 3k omega square m plus k square is equal to 0. So here our challenge is to find the value of omega. So this is a quadratic equation. So we will calculate the value of omega square, that is roots of this equation. Then omega square is equal to minus b, then it will be 3k m plus minus under root b square 9k square m square minus 4ac, then 4 m square k square upon 2a. then it will be 2m square. In the next step, m will get cancelled, then we will get 3k plus minus under root 5k upon 2m, and if we will, for the value of omega r, omega 1 is equal to 3k minus under root 5k upon 2m, and the value of omega 2 is, here we have whole under root, omega 2 is equal to under root 3k plus under root 5k upon 2m, and in the next step, here we have to calculate the ratios of normal modes of frequencies. So omega 1 is to omega 2 will become under root 3 minus under root 5 is to under root 3 plus under root 5, and if we will check our option, then option 1 is the correct answer. So this is from my side of solution. If you like my problem solving technique, then please like, share and subscribe my YouTube channel. That's all. Thank you.